Let's take a look at an example. For the system shown below, we want to find the following items. We want to know the damping ratio zeta, the natural frequency omega n, the gain, and the response type. So we have a block diagram with our transfer function g of s, and of course we have an input that can be put in, r of s, and an output, c of s, that corresponds to that input. But we don't need to know any information about our input to find any of these four things we're looking for. So first, for our first item, from inspection we can figure out what our a and b variables are. So from inspection of our transfer function, we have that a is equal to 8, so we see that from here. Now you might be asking yourself, from our first general equation with a and b, we had b in two locations. We had b in the numerator and b here. So which one of these two is b? And so the answer to that is, when in doubt, always go with this term in the denominator, because this term in the numerator, the 40, also has the gain incorporated in it. So in this case, we have that our a is 8 and our b is 20. From there, we can use the equations from the previous videos that relate our zeta and our omega n to our a and b. So we can say our damping ratio zeta is equal to a divided by 2 root b. Plugging in, we have 8 divided by 2 times the square root of 20, which is approximately 0.894. Now, of course, we don't necessarily need to solve for these four things in any order. We could do it sort of differently, but let's go ahead and move on to our natural frequency omega sub n. So our omega sub n is simply equal to the square root of b. So omega sub n equals square root of b, which we already said b is 20, so square root of 20, which is approximately 4.472. Okay, so that's how we get that. Now for our gain, what we want to do is we want to sort of rewrite our transfer function such that we have our unity gain expression multiplied by some constant term. So for our unity gain expression, that's where we do have this term in the numerator the same as the last term in our denominator. So if we want that, we can write 20 here, and then we just copy down s squared plus 8s plus 20, so that shouldn't change at all. So what we have right here is our unity gain expression. However, of course, that's not equal to what we see in the box up here at the top for our g of s. In order to get that 40 in the numerator, we have to multiply this expression by 2. So in that case, this 2 is our gain. So gain for our system is equal to 2. Finally, for part 4, our response type, all we have to do, remember, is look at the value of our damping ratio zeta. So in this case, we see that our damping ratio is between 0 and 1. So zeta is between 0 or 1, which indicates that we're going to have an underdamped response. So pretty simple as far as how to apply these equations. What we're going to look at in an example a little later on is how we can go all the way from the physical system to our equations for our transfer function to our damping ratio and response type. Before we do that though, what we're going to do is get into a little more detail for our underdamped second order systems.